Hi, my name is Caroline Key, and I'm doing Khan Academy problem 19.4 of electrochemistry. In this problem, you need to construct a voltaic cell for an experiment. You look on the shelf and you have a manganese electrode and a silver electrode, as well as soluble salts of both metals. Fully label the diagram below and calculate the value of E cell and delta G for the cell if you had A, 1.00 molar solution of both salts, and B, 1.25 molar solution of the manganese salt and 0.076 molar solution of the silver salt. So let's start off by labeling the diagram below. On the left side, we have the manganese, which is oxidizing, meaning it is the anode. And on the right side, we have the silver, Ag, which is reducing, meaning it's the cathode. And for our salt bridge, we are using NaSO3 and Na2SO4. And as you can see, the electrons will travel from the anode to the cathode. So let's write down their half reactions, which are Mn solid react to become Mn2 plus aqueous plus 2 electrons. And then silver is Ag plus aqueous plus 1 electron, becoming Ag solid. Since manganese has 2 electrons, we have to multiply the silver half reaction by 2 to be able to cancel out the electrons. And then our full reaction will be 2NO3 minus plus Mn solid plus 2Ag plus aqueous react to become Mn2 plus aqueous plus 2Ag solid plus SO4 2 minus. Now the 2NO3 minus and the 2Ag plus make the silver salt, and the Mn2 plus and SO4 2 minus make the manganese salt. So now we are going to find the E cell and delta G of the salts if we had a 1.00 molar solution for both salts. So to find the E cell, we are going to use the equation E cell equals E cathode minus E anode. Since the silver is the cathode and manganese is the anode, it will be the E cell value of Ag minus the E cell value of manganese. So you can find these values in the half reaction chart that is given to us inside of our notes. So 1.99 minus negative 1.18. This equals 5.16 volts, or 5.16 joules per coulomb. Now, to find the delta G, we are going to use the equation delta G cell equals negative NF E cell. So N is the amount of moles, which is 2, and then F is a given constant, which is 96,485. And then E cell is the value we just calculated. So let's plug this all in. G cell equals negative 2 mole electrons times 96,485 moles electrons times 5.16 joules per coulomb. And then the total value of this is going to be negative 995,880 joules. For part B, find the value of E cell and delta G if we had a 1.25 molar solution of the manganese salt and 0.076 molar solution of the silver salt. So to find our E cell, since we have two different molar solution values, we are going to use this equation. E cell equals E cell minus RT over NF times log of product over reactant. Or to simplify it, E cell minus 0.0592 over N times log of the product over reactant. So let's plug in our values that we have. The E cell will be the E cell we just calculated in the previous problem. And then 0.0592 over 2 moles, 2, times the log of 1.25 molar solution over 0.076 molar. And then the total value will be 5.112 volts. That is our E cell value. And then to find the delta G, we do the exact same thing as part A. We plug it all into the equation. Delta G cell equals negative NF E cell. So yeah, delta G cell equals negative 2 moles electrons times the given constant of 96,485 C mole times 5.12 joules per coulomb, which is the value we just calculated, and the total value is negative 988,160 joules. So a little recap of the entire problem. This is part B, where we found the E cell and delta G of both the manganese salt and silver salt when they have different molar solutions. So the E cell is 5.12 volts, and then the delta G is negative 988,160 joules. And then for part A, where we calculated the E cell and the delta G for the cell, if both the salts had 1.00 molar solutions, the E cell was 5.16 volts, and then the delta G was negative 995,880. And then in the beginning when we labeled the diagram. Thank you for listening to my problem.